Welcome to Basics Revisited. In this video we explore two foundational ideas in mathematics: relations and functions. So, what is a relation? Let us start with a real-life example. Ravi likes cricket, Priya likes tennis. This liking connects two sets of people and sports. That connection is a relation. Formally, a relation R from set A to set B is any set of ordered pairs A, B, where A belongs to A and B belongs to B. We write R as a subset of across B. For example, if A equals 1, 2 and B equals A, B, C, then R could be the set containing 1, A, 1, B, and 2, C. Let us look at a diagram. Set A has elements 1, 2, and 3. Set B has elements A, B, C, and D. The arrows show which elements are related. Notice that element 2 maps to both B and C, and that is perfectly allowed in the relation. So R equals a set of pairs 1A, 2B, 2C, and 3D. Now, what is a function? A function is a special kind of relation. Think of it like a seating plan in an exam hall: every student has exactly one seat, no student has two seats, and no student is left out. That one-to-one assignment is a function. Formally, a function f from A to B is a relation where every element of A is mapped to exactly one element of B. How do we check if something is a function? Look at three cases. First, if element 1 maps to both A and B, that is not a function. Two outputs for one input. Second, if each input maps to exactly one output, it is a function. The rule is satisfied. Third, if element 3 has no output at all, that is also not a function. Every input must map somewhere. Now let us learn how to write functions correctly. Step 1: name the function and its sets. Write f: A arrow B. Here f is the name, A is the domain, meaning all allowed inputs, and B is the codomain, meaning all declared possible outputs. Step 2: write the rule. For example, f of x equals 2x plus 1, meaning for any input x, the output is 2x plus 1. Type 1 is the 1, or injective function. Different inputs always give different outputs. Mathematically, if f of x1 equals f of x2, then x1 must equal x2. In the diagram, elements 1, 2, and 3 each map to unique targets A, B, and D. Notice that D in set B is left unused. That is perfectly fine in an injective function. Type 2 is the onto, or surjective, function. Every element of B must be reached by at least one element of A. Formally, for every B in B, there exists some in A such that f of A equals B. In our diagram, elements 1, 2, 3, and 4 together cover all of A, B, and C. In set B, all of B is covered. Type 3 is the bijective function. It is both 1 and onto simultaneously. Every element of A maps to a unique element of B, and every element of B is reached. This makes the function invertible: the arrows can go in both directions. Bijective functions are perfect pairings between two equally sized sets. Types 4, 5, and 6 are many one, constant, and identity functions. In a many one function, multiple inputs can share the same output like elements 1, 2, and 3 all mapping to A or B. A constant function maps everything to a single value k. Every input gives the same output. An identity function maps each element to itself. Input 1 gives output 1, and so on. Let us clarify three important terms. The domain is set to all allowed inputs. The codomain is set to all declared possible outputs. The range is the set of actual outputs used. It is always a subset of the codomain. In our diagram, C is in the codomain but not in the range, because no element of the maps to C. Finally, let us solve the function problem. Given f of x equals x squared minus 3x plus 2, find f of 3 and f of negative 1. For f of 3 colon substitute 3. 3 squared minus 3 times 3 plus 2 equals 9 minus 9 plus 2, which equals 2. That is our answer. If you found this video helpful, please like, subscribe, comment, and share. Thank you for watching Basics Revisited.